We hope you are enjoying your training workshop today, because you hold the key to unlocking one of Europe's most ambitious energy targets. By 2020, the European Commission wants every new building that you design and build to be a nearly zero energy building, taking energy efficiency to new heights. This goal is at the heart of PVSITES project and this workshop today. It's a very real and relevant goal for us all because our buildings are responsible for around 40% of the EU's total energy consumption and a third of all CO2 emissions. BIPV, building integrated photovoltaics, is a vital component of every nearly zero energy building. Europe leads the world's BIPV market, but architects, engineers, urban planners and construction companies across the EU have raised technical and commercial concerns about BIPV, about flexibility in design, architectural integration, reliability, cost-effectiveness and smart interaction with the grid, which is holding back the kind of uptake we need. That's why PVSITES project created a series of high-impact demo sites in 2016 to help create a large market for BIPV by bringing BIPV to life, showing the latest solar technology in action in real time in a range of climates, and proving that BIPV is a forceful, reliable answer to cost-effective renewable generation and the reduction of Europe's energy demands. 3 years on, you are about to go on a virtual tour of Europe to see the results. In San Sebastian, a fashionable resort on Spain's northern coast, 2 symmetrical ventilated BIPV facades have been successfully installed at the 4-storey Tecnalia building, which is home to offices and laboratories. The singular geometry of the original facade created challenges, but this demo site proves concerns about architectural integration and the installation of the BIPV technology at an office building can be overcome. The demo site used glass-back contact crystalline silicon cells produced by Onyx Solar, covering 170 square metres. The installed power is 10 plus 10 kilowatt peak. The electricity now being generated is used by Tecnalia and the grid. In Barcelona, on Spain's northern-eastern Mediterranean coast, the roof of this industrial building has been retrofitted with thin-film CIGS shingles. The large roofing shingles have been carefully integrated into the roof structure, in harmony with the visual appearance at the precursor site. This demo site proves concerns about aesthetics at an industrial building can be overcome. The demo site used CIGS shingles on a metal substrate produced by Fleesum, covering 225 square metres. The installed power is 19 kilowatt peak. The electricity now being generated is used by the grid. In Zurich, Switzerland's largest city and one of the most important financial centres in the world, 2 solar carports have been built, one at the EMPA headquarters in Dubendorf and the other in Soisach. The carports have been built around purpose-made curved metal roof tiles covered with CIGS thin-film PV. There are charging points for electric vehicles, so the electricity being generated by the PV can be used directly by the motorists who park at the carport. This demo site proves concerns about combining both function and design can be overcome. The demo site used CIGS on metal sheets produced by Fleesum, covering 145 square metres. The installed power is 7 plus 7 kilowatt peak. The electricity now being generated is used by the EV charging points and the grid. Geneva, which is surrounded by the Alps and Jura mountain, is home to the prestigious École Hôtelière de Genève, known as EHG. The school site is made up of 3 buildings that are interconnected by teaching facilities underground. The main historical centre of the school dates back to the 18th century. Large tiles will be fitted to the school's facade. Production and the installation work is ongoing, but this demo site proves that BIPV technology can be fitted at educational sites which often include a mix of old and new buildings. The demo site will be using CIGS shingles on a metal substrate produced by Fleesham, covering 136 square metres. The installed power will be 4 + 8 kilowatt peak. The electricity will be used by École Hôtelière de Genève and the grid. Stambrouge is a town in Belgium surrounded by forest, close to the border with France. This single residential property was built in 2016 to passive and bioclimatic standards. For PVSITES project, a BIPV roof made up of roofing shingles has been installed, which is expected to make the house an Energy Plus building, which means the owners will produce more energy than they consume each year. This demo site proves that new buildings are highly compatible with BIPV technologies with careful architectural design and integration. The demo site used CIGS on steel produced by Fleesham, covering 75 square metres. The installed power is 8 kilowatt peak. The electricity now being generated is used by the homeowners and the grid. And in Lille, the fourth largest city in France, a ventilated BIPV facade has been successfully installed at this apartment block. Getting permission for the BIPV installation was complicated on this project, because this is a public housing building. The design of the BIPV facade also had to suit an architectural retrofit taking place at the block. This demo site proves concerns about planning and permissions can be overcome, and the effort this takes is more than worth it. One of the main objectives for installing BIPV at this location in Lille was to significantly reduce the electricity bills for the building, which will benefit the tenants. The demo site used crystalline silicon cells, modules with hidden bus bars produced by Onyx Solar, covering 130 square metres. The installed power is 17 kilowatt peak. The electricity now being generated is used by tenants at the apartment block and the grid. So across Europe, PVSITES project has created a series of high-impact demo sites which have tested the latest BIPV technologies at every stage, from planning to installation to energy generation. The results you have seen today prove beyond doubt that BIPV is a forceful, reliable answer to cost-effective renewable generation and the reduction to Europe's energy demands.